Hi, everybody. Let's talk about section 5-6. This section is the last one in this chapter, and we're going to be graphing inequalities in two variables. Guess what those two variables are? If we've got an x and a y, we've got an x and a y axis. So we are back to graphing lines on a coordinate plane. So let's do a quick review. Number one, it says to sketch the graph, it says y equals negative 1/3 x plus 4. Well, we can graph that, right? So this is an mx plus b form. So what is my b and what is my slope? Go ahead and put that on your graph. I know I'm going to begin with the 4 and I'm going to move with the slope. Everybody remembers that we go down 1 and right 3. Connect those guys. We have got ourselves a line. We're going to do that in this section, 5-6, only this time around, we're going to throw an inequality in there instead of the equal sign. If you notice in problem number 2, 2x plus 2y equals negative 6, not an mx plus b form. So you got a couple options. You could put it in y equals mx plus b. You could also find the x and y intercepts if you remember how to do those. That would be a good way to do this as well. So either one of those would be good ways to graph it. Hopefully you remember all that from chapter 4, but this is what we're going to have to do. So let's talk about graphing linear inequalities. So first thing, if it needs to go into mx plus b form, do so, or if you need to find the x and y intercepts. I guess I should add that, or find x and y intercepts. I'm okay with that as long as you know what you're doing. Remember, your work should show me that you know what you're doing. Otherwise, I don't know what you're doing. We are going to sketch that graph, put points on it so we have things to connect. However, here's where things start to differ. I'm going to put a little squiggle right here. Because usually in chapter 4 and before, we would just connect the dots, put arrows on either end, and we're good to go. Well, now we need to think about this as an inequality. So you know how when we graphed inequalities on the number line, we had open and closed circles? Well, when we graph lines on a coordinate plane that are inequalities, we need to decide if we've got a dashed or a solid line. Same rules apply. If it's solid, it's going to have the or equal to, the line underneath it. If it's dashed, it's just a less than or a greater than. And the last thing that we need to do that is different, even more different than just the open and closed circle or the dashed or solid line, is we need to shade the graph. So we're actually going to put a line, we're going to have a dashed or solid line, and then we're going to color in, shade in part of that graph. In order to know where to shade, you're going to test a point. So you're going to pick an x and a y ordered pair. You're going to put those values in for x and y and see if you've got a true or a false statement. If it's true, you want to shade where the point is. Shade where that point is. If it's false, you want to shade on the other side of the line. You don't want that point shaded. I'm going to put it that way. You don't want that point shaded. So we'll do an example or two so you can see what I'm talking about. I'm going into this section thinking that you remember how to graph a line. So if you don't, you might need to go back to chapter 4. I believe that section 4.1 was graphing in slope-intercept form. The other thing that I need to say is when we test a point, the easiest point to test is the origin. So I always use 0, 0 unless it's on my line. Then I have to pick something else like 1, 1 or 1, 0 or something like that. So I'm always going to use 0, 0 unless it's on the line, because if it's on the line, it's not going to give us a good sense of true or false because we've got an inequality there. So it's really not helpful. So always use 0, 0 if you can. It's the best way to go. All right, so let's do a couple graphs. Quick and painless. I like this one. Sketch y is less than or equal to 2x minus 4. Notice instead of our equal sign, we've got a less than or equal to, but it's still an mx plus b form. In other words, the y is isolated, and we can pick out the b in the slope. So the b is negative 4. The slope is 2. Of course, we can write that as 2 over 1. So I'm going to go to negative 4 on my graph. I'm going to go up 2, right 1. Now, before I connect these and call it good, I need to decide if this is going to be a dashed or a solid line. Sometimes I even look at this right at the beginning so I don't forget to check. This is what tells me if it's dashed or solid. So since it's a less than or equal to, it's going to be a solid line. So I can just go ahead and connect these dots. Before I walk away, I also need to look at the shading. Is 0, 0 on the graph? It's not, right? 0, 0 is sitting over here on the left-hand side of that graph, so we're good to go. So I'm going to go back into my original equation. I'm going to put a 0 in for x and a 0 in for y. So 0 is less than or equal to 2 times 0 minus 4. So what's 2 times 0 minus 4? 0 is less than or equal to negative 4. Is that true or false? 0 is less than or equal to negative 4. I don't think so, right? Negative 4 is less than 0. So since that's false, here's 0, 0. I don't want that to be the shaded part, so I'm going to have to go to the other side of that line and shade over here. If it were true, I would want 0, 0 to be in the shaded part, so I would shade the left-hand side of that line. So we're going to sketch, we're going to decide on the line, and we're going to shade. One more example. Let's do this one. 2y minus 4x is less than 6. It is definitely not an mx plus b form. I'm going to go ahead, I'm not going to do the x and y intercepts. I'm going to solve for y. So in order to do that, I'm going to add 4x to both sides. You can put that line down there if you like that to keep them separate. So I'm going to have 2y is less than, just keep bringing down your inequality. It's a positive 4x and a positive 6. In order to get that y by itself, I'm going to divide everything by 2. So y is less than, I don't need to flip over my inequality because my 2 that I'm dividing by is positive. That should be a 2x plus 3. So now I know my b and I know my slope. So up 1, 2, 3 for my b, and then I'm going to move up 1 and up 2 and right 1. Sorry. Run out of space. I could always go down 2 and left 1. Before I go ahead and just connect those dots, I need to look and see, is this going to be a solid or a dashed line? So I go back to this. This less than doesn't have an or equal to, so it's going to be a dashed line. So when I draw it, I'm going to just go like this. I have seen some teachers have their students make the line but then do this to show that it's dashed. I would be okay with that if you like that. I think it looks messy like a bunch of train tracks, so I'm going to just do the dashing like that. But either way would be okay. And last but not least, before we walk away from this, we need to decide on the shading. Are we allowed to use 0, 0 for this? Looks like the line doesn't touch the origin, so I'm good with that. I'm going back to my original equation. You can go to the original or you can go to the y equals mx plus b form. Either way, you'll get the same answer. I'm going to go to the original. So 2 times 0 minus 4 times 0 is less than 6. 2 times 0 is 0. 4 times 0 is 0. 0 minus 0 is 0. 0 is less than 6. Is that a true or a false statement? True, right? So we want 0, 0 to be in the shaded part since it's true. So 0, 0 is right here. So I'm going to shade this side of my dashed line. Notice how in the last example and in this example, both of them got shaded to the right, but for different reasons. It's all about where that test point is. I want 0, 0 to be on the shaded side of the line because I got a true statement. So it's all about what point you test and whether it's true or false. So that is our graphing of inequalities with two variables. Let's do a quick talk about ordered pairs that satisfy. The word satisfy is kind of a strange word to use in math, but satisfy means that it makes it true. So a solution set of an inequality is the set of all ordered pairs that satisfy or make the inequality true. In other words, if you plug the ordered pair, the xy, into the inequality, you will get a true statement, much like we just did with that testing of the point 0, 0 on that second problem. 0, 0 satisfied the inequality. It made it true. The first one, it did not. We had a false statement. So from that set, 1, 6, 3, 0, 2, 2, 4, 3, which ordered pairs are part of the solution set for that inequality? So I've got a 3x plus 2y equals, or sorry, 3x plus 2y is less than 12. So I'm going to test out this point, 1, 6. So this is my x and this is my y. So 3 times 1 plus 2 times 6 is less than 12. Do a little math. 3 plus 12 is less than 12. That's not true, right? That's big old false. So 1, 6 is junk. Let's test out the ordered pair, 3, 0. Go back to my original equation. So 3 times 3 plus 2 times 0 is less than 12. Well, that's 9 plus 0. That's true. So this is a part of my solution set. The thing is, once you find one, you still have to keep going. There could be more than one answer. So let's check out 2, 2. X and y. Back to my original equation, 3 times 2 plus 2 times 2 is less than 12. Well, 6 plus 4, less than 12. That's true. I like this one. And last but not least, 4, 3. So back to my original equation, 3 times 4 plus 2 times 3 is less than 12. Well, that's 12 plus 6. Whoops. I put the answer instead of the 12 plus 6, is that less than 12? Definitely not, so that one's junk. So I have two ordered pairs that made that inequality true. So my solution set is 3, 0 and 2, 2. I disregard the other two that I got false statements for. So really, that's just a plugging in the numbers and checking to see if you get a true statement. And that is it for section 5-6. So please tell me, how do you know whether to graph using a solid or dashed line? Kind of an important thing to remember to check. So how do you know whether it's solid or dashed? And which ordered pairs satisfy the inequality? I should have put inequality here. Whoops. X minus 3y is greater than 9. I gave you three ordered pairs to check. Tell me which one or ones give you a true statement. That is it for section 5-6. Bring your questions to class. We'll talk to you next time.